Hey Calculus kids, this is Dr. Callahan with week 16 Friday. Yay, we made it to the end. Go ahead and pause the video for your following 3 questions for your warm-up. Keep in mind it's due on week 18. I'll give you guys more information as to how you can submit it as we get closer to that date. All right, let's go ahead and get started. Let's start off with MS Team first. And of course, just keep in mind that every day you need to go ahead and view the assignment in addition to uploading it if it requires to be uploaded. Keep in mind that your Math Excel on a week 16 Wednesday is due, so make sure you guys are doing that. So let's go ahead and create the assignment for week 16 Friday. So this is week 16 Friday. It is for Calculus AB Semester 1. And today we're going to talk about differentials, which is kind of like max and min application questions. I'm going to go over as a quick review. And I should put differentials and review day of unit 3. Okay, and then of course your instructions for today is going to be as follows. And before I do that, I want to make sure I go ahead and give you guys the PDF version of today's notes, just in case if you have not received the hard copy. And just keep in mind that the hard copies are outside the door if you need it of B1. The building is open Monday through Friday from 7:45 until 3:30. So you're welcome to stop by any time to grab that. If you also need the guided notes for week 1 to week 9 of semester 2, because the school board has approved that the first week that we guys come back from winter break is going to be hybrid as well, or I'm sorry, is going to be full-time distance learning as well. And so you will need to have your notes for week 1 of Monday through Friday for semester 2. And of course, if you guys need it, I do have copies of the first quarter, the first 9 weeks of semester 2 outside of my classroom. So you're welcome to stop by and pick up a copy. Or if you have a printer at home, then please go ahead and do that. I just want to make sure you guys are not falling behind. So here are your instructions. Your guided notes for week 16 to 18 is right here. Your assessment correction template is right there for any of the assessment from AP College Board on Wednesdays. Some of you guys have emailed me that you've done additional ones or you've turned it in, so thank you for that. I will update your grades accordingly. Make sure you guys view the assignment, watch the video, fill out the guided notes. If you have any questions, every day I have a Zoom meeting from 10 to 10:30, and if you need additional tutoring time, I can go ahead and set up a tutoring on a different time with you guys. Same meeting code, same password. If you need a hard copy of the guided notes, just keep in mind they are outside of my door, so please do that. And if you have questions, I have my email right here as well. Your Calculus AB is right here. There's actually a yellow envelope separating the two. The one on top is for semester 2, week 1 to week 9. The stack on the bottom is for semester 1, week 16, 17, and 18. So just keep that in mind. All right, so I'm gonna go ahead and assign this so I can post it. Let's go back to Teams, and I'm going to go ahead and upload your PDF of week 16 Friday's guided notes. So if you would like to print out just today's notes, you have that available. And there it goes. It just popped up. So I'm just going to click on reply and then attach today's guided notes to that as well. Week 16 Friday. And attach. Here we go. It's getting there. It's taking a little bit of time, but that's okay. And send. Okay, so then if you click on the link today for the guided notes, You'll be able to see the warm-up log in addition to all the things we're going to talk about today. So if you just want to print the guided notes for today, for week 16 Friday, it's thinking right here. There are 72 pages, so obviously you don't want to waste the ink cartridge for 72 pages. You want to start printing from page 69 to 72, and there are 4 pages. So if you take a look at this right here, it is a review. Here's page 1 of unit 3. We're going to go over a few examples here. Page 2, and then I have these 3 questions are from your textbook. I would suggest that you guys go ahead and start working on it. If you run into trouble with us, then click on this link right here and watch the video, as it does go over differentials with you guys. And then lastly, this is a unit 3 checklist of all the materials that we've talked about, from optimization all the way to the very beginning of roles and mean value theorem. So it's a concept summary of everything that we discussed. All right, so with that said, let's go ahead and get started with today's lesson. When I saw you guys last time, yesterday, we actually went over, I asked you guys to go ahead and go over several of the examples, real life problems involving optimization versus related rates. So today I would like to go over the following from yesterday. So these are the questions from related rates. These are the questions from optimization. I told you guys that, you need to understand the difference between the two, because those are the more difficult questions. We did related rates back in unit 2 when we first talked about derivatives. And then of course we did optimization in unit 3. These are all the word problems of applications that for calculus. And then of course you have your answers and steps from these specific links. So this is what you should have done from week 16 Thursday. So today I want to go over a few questions with you guys on this from yesterday. All right, so here's one of the questions from related rates. Okay, it says a tank of water. Okay, hold on a second. I can't see my pen. Okay, there we go. A tank of water in the shape of a cone is leaking at a constant rate of 2 cubic feet per hour. The base of the radius is 5 feet and the height of the tank is 14. At what rate is the depth of the water in the tank changing when the depth of water is 6 feet? And at what rate is the radius of the top of the water changing at a depth of water 6 feet? Okay, so there are a few things. Number one, you want to make sure you kind of draw a picture so that way you have an idea as to how to go about doing this. Next, what you want to do is you want to go ahead and find H. And so as I'm looking at this right here, you can draw your tank however you want. So it's leaking at a constant rate of 2 cubic feet per hour. So just keep that in mind. The base of the radius of the tank is 5. And the height of the tank is 14. So here I drew my pictures. First step is you want to go ahead and find H prime of H prime. So if you look at this right here, you know H over R, or the height over radius, is 14 over 5. Now, if you want to find H prime, you will have to solve for H. So let's cross multiply this. So I have 5H is equal to 14R. And then H is going to be 14R over 5. Okay, now from there, for number 2, you're given the fact that H prime is going to be equal to 14 over 5 times R prime. And you know that R prime is going to be 15 over 4 times H prime. And it's also given to you that from here, that if I were to go ahead and replace H prime, you know from this point here that H prime is going to be equal to negative 98 over 225 pi. So then as such, I'm going to take this part and replace it right here for H prime, which then takes us over to number 3. So at this point here, you're going to get R prime is equal to 5 over 14 times H prime, which is 98 over 225 pi. And if I algebraically solve this, or if I just go ahead and take this part, put it into a calculator, get a decimal, it's going to give me a 5 over 14 times negative 0.1386. And then from there, my last part here is that R is going to, or R prime is going to equal to, and I want to go ahead and multiply this out. So you're going to take your calculators and just multiply it out. R prime is going to equal to negative 0.04951. And that is going to be the rate of the radius at the top of the water in the tank. Then what rate is the depth of the water? Well, you found that it's right here. So that answer is A, and this part answers B. Okay, now let's go ahead and go over one of the questions for optimization. Okay, so let's talk about this one here. It says a manufacturer needs to make a cylindrical can that will hold 1.5 liters of liquid. Determine the dimensions of the can that will minimize the amount of materials used in the construction. Okay, so first thing you want to do is you want to go ahead and draw a picture of this. And so it's making a cylindrical can. And I decided to pick the same example because since the other one is a cylindrical can as well, and it's on related rates, this one is a cylindrical can on optimization problems. So with optimization, just remember you need to have a primary and a secondary equation. All right, so I know that it needs to hold 1.5 liter of liquid. So first thing I know it's given to me is that the volume is 1.5 liters, okay? The question here asks you to determine the dimensions of the can that will minimize the amount of materials used. Okay, so materials used to me talks about surface area. And so the question is asking for surface area. So therefore surface area is going to be your primary equation, and volume, which is given to me, is going to be your secondary equation. So then let's take a look at this. So let's label it. Here's your R. Here's your H. And since we're talking about surface area, we would need to figure out how do you find the surface area of a cylinder. Well, if you take a look at this, if it's like a can and I decide to roll this out, notice that what's on the surface of this can? I notice that there are 2 circles, top and bottom, plus if I roll this length out, you have this little roll right here, right? So how do you find the area of a circle? Well, that's going to be pi r squared plus pi r squared plus, and how do you find the area of this thing right here? That's just going to be, remember, the top part is going to be the circumference of a circle. And how do you find the circumference of the circle? It's 2 pi r times however much the height of this item is going to be. And so that is going to be times h. And this right here is the surface area of this can. Second step, you want to convert the 1.5 liters to centimeters cubed, because it's given to you that if you're going to deal with the volume, you need to convert it over to centimeters cubed. So then looking at this, 1 liter equals 1,000 centimeters cubed, so 1.5 liters equals 1,500. Third step, what is the volume of the cylinder? Now going back to geometry, the volume of cylinder is always the area of the circle, which is pi r squared, times the height of the cylinder. So then from here, since I know that the volume is 1,500, I could take 1,500 and set it equal to pi r squared h. Now this is your secondary equation. So remember, you're going to use your secondary equation to solve for one of the variables and substitute it back into the primary equation, which is going to be your surface area. And the reason we want to do that is because if you look at your surface area, you have R and you have H, and you can't have both of them. You want to have just one letter. I'm going to keep my R, so that means I want to replace the H. So if I go back to my secondary equation, that means I want to go ahead and solve for H. So that way I can take H and replace it back into the primary. So looking at the secondary equation, if I were to solve H, H is just going to equals 1500 divided by pi r squared. All right, so the goal is to find the dimensions to minimize the amount of materials. I got to figure out what my R is and my H is, and remember this is in centimeters. So then the primary equation of the cylinder is going to be 2 pi r squared plus 2 pi r h. And then what I'm going to do is I'm going to take the h that I just found here, substitute it into the primary equation, so that way I have just one variable. And so the cylinder is, the surface area formula is going to be 2 pi r squared plus 2 pi r times the height, which is 1500 divided by pi r squared. And of course, we can go ahead and simplify this a little bit further. And by simplifying, I can take the 1500 times it by 2, which will give me 3000, and that'll be 2 pi r squared plus 3000. Notice the pi cancels, r and r squared cancels, which leaves with an r in the denominator. Next, I want to find the SA prime, which is the first derivative of the surface area. It's going to be fairly easy because you're just going to do a simple power rule. So bring down the 2, you get 4 pi r minus, and if you guys go ahead and take a look at this part here, what is the derivative of 3000 over r? Well, you can rewrite this as 3000 r to the negative 1 power. So if you bring down that negative 1, you have a minus 3000, and then r to the negative 2nd power, which if I bring it down would just be r squared. And if I need to rewrite it, that's exactly what I will have. Okay, so next what I want to do is I want to go ahead and find the critical point by setting S prime of A equal to 0 and solving for R. So from the last one, you know that SA prime is going to be 4 pi R minus 3000 over R squared. Let's set that equal to 0. And we're going to go ahead and subtract the 4 pi R on both sides. And so then what I will have there, well, actually, you know, see, I can subtract that over. Let's move this one over. If I do that, 4 pi r equals positive 3000 over r squared. There's a 1 right there. So we're going to go ahead and cross multiply. So I have 4 pi r to the third equals 3000. Your goal is to get r by itself. So you have 3000 divided by 4 pi. And then you're going to go ahead and cube root the 3000 over 4 pi. So the best thing that you can do is first put 3000 divided by 4 pi in your calculator. That's going to give you a decimal. And then from that, do the outside of the cube root. And you should get two answers, a positive and a minus 6.2035 centimeters. So after that, keep in mind you can't have a negative, so we're not going to have a negative radius. It's only going to be a positive radius. And so let's go ahead and test this, excuse me, on a sine line. So I'm just rounded as 6.2. So then I'm going to do a f prime on the left side of this. So that could be a 5, and f prime on the right of this, which could be a 7. And then I'm going to plug this into my first derivative equation, and just keep in mind your first derivative equation is right here. And I shouldn't put like f prime because I'm so accustomed to using f prime, but really it's actually sa prime. So let's change that. And that does matter if you're doing this on a free response question. If you plug this inside here, you'll see that SA prime 5 is going to give you a negative, and S prime of 7 is going to give you a positive. So here I have a negative and a positive. And so what this tells me is that when x equals 6.3, this is a minimum, which actually works well because that's exactly what I'm trying to prove with the question. It's asking you, what is the dimension of the can that will minimize the amount of materials used on this? So it is a minimum, so that's awesome. Your dimensions for the radius is going to be 6.2 centimeters. So then if you need to find the height, you're going to have to go back to last page, which we actually did find h, and h was 1500 over pi r squared. So plug in the r, that's going to be 1500 over pi times 6.2 squared. Use your calculator and you'll be able to find that if the manufacturer makes a can with a radius of 6.2 centimeters, the height is going to result in 12.4 centimeters, which is the least amount of materials that will be needed to make the can itself. All right, so with that said, those are the two questions, one on related rates, the other one on optimization. So if you need some additional practice, make sure you guys go back to week 16 Thursday and take a look at some of the other examples. The steps are given to you as well. All right, I'm going to go ahead and get started with today's stuff. So first I want you guys to do is take a look over here. This is your chapter 3 checklist of all the concepts that we talked about. And just take a moment and read it. You could pause the video. Okay, so then let's go ahead and go over the review of Unit 3 from today's stuff, which is week 16 Friday. This is actually the first question, so make sure you guys turn over to this. There are 2 pages of this. Here's the test review for it. This is the first page, and then of course this is the second page. So let's get started with the very first question. It says a t-shirt maker estimates that the weekly cost of making t-shirt is C of X equals that entire thing. The weekly revenue of selling X t-shirt is given by R of X. So A asks you, what is the profit if the t-shirt made are sold, which is profit is equal to the revenue minus cost, which makes sense because revenue is how much you actually sold the t-shirt for, and the cost is the amount of money that you're spending to make the t-shirt. So you will have to subtract the two, and hopefully your revenue is going to exceed the cost of you actually making the t-shirt, because if it's a negative, then that means you have a really bad business model. So let's take a look at this. P of X is equal to, which is the profit, okay, is equal to revenue, and the revenue is going to be 20x plus x squared over 200 minus the cost. Minus the cost means that negative is going to be distributed to everything here for C of X. So that's going to be a minus 50 plus 2x plus x squared over 20. Make sure you distribute that. So that becomes a plus, that becomes a minus, that becomes a minus, that becomes a minus. I would suggest let's go ahead and simplify this a little bit further. So I have 20 minus 2 is going to give me an 18x. And then I'm going to have a negative 50 plus I have x squared over 200 minus x over 20. So with that, you will have to have a common denominator minus x squared over 20. So in order for the 20 to get to a 200, I will need to multiply by 10 on top and bottom. So then on top, I have a negative 10x squared. So what's negative 10x squared plus 1x squared? That's going to give me a negative 9x squared over 200. And this is my P of X. Okay, so then B is what is the maximum weekly profit? So given the fact that it's asking you about maximum weekly profit, you're looking at P prime of X, which is what I'm trying to find. So let's go ahead and find the derivative of this P of X. So the first one is just 18 minus. You can go ahead and think of this as kind of the power rule. Take the 2 down, so bring that down. Just think of 9 over 200 as a constant. So if you bring the 2 down, it'll just give you 2x. So 2 times the 9, x over 200. And if you simplify that, 18 minus 18x over 200 equals 0. You want to find the critical point of this, so let's go ahead and solve for x for the critical point. Subtract the 18 on both sides, you have a negative 18x over 200 equals negative 18 over 1. Cross multiply, you have a negative 18x equals 18 times 2 is negative 36, but there are 2 zeros, so negative 3600. And then divided by 18, x is going to give you a positive 200. And since we're looking for the maximum weekly profit, given the fact that x equals 200, you're going to take this and plug it back into P of x to find the weekly profit. So P of 200, and this is your equation, is equal to 18 times 200 minus 50 minus 9 times 200 over 200. And that should result in $1,750. All right, so what I would like you guys to do right now is go ahead and practice with the rest of this. So move on to question number 2, 3, 4, so on and so forth. If you need the steps, feel free to type in the link right there. Pause the video and answer those questions. Okay, I'm going to go over question number 8 on this. So go ahead and read question number 8, which is on a manufacturer trying to build a open box. Actually, you know what? Let's see if I want to do that. I felt like we did one very similar to this one. So maybe let's do number 7. Number 7 might be a better alternative. Yeah, let's do number 7. Sorry about that. Okay, so on question number 7, it says Max plans to build a two side-by-side identical rectangle pens for his pigs that will enclose a total area of 216. What is the minimum length of fencing he will need? So first thing I want to do is let's go ahead and draw a picture for this. Since it's talking about the minimum length of the fencing and it's given to you area, so area is going to be the secondary equation. Minimum length of fencing means its perimeter, so that's going to be your primary equation. So you just want to make sure you label that so you have a good understanding. So let's take a look. So let's draw the fence first. Now there's going to be a separation here because it's going to be two side-by-side rectangular pens for his pigs. So if I say that this entire length here is x and this is y, then the middle is y, the end is y, top part here is x, then the perimeter of this building the fence, the materials you need is going to be 2x plus 3y. And I don't want to have an x and a y, I just want to have one variable, but that's where the secondary equation comes in because it's going to help me isolate one of the variables to be able to find the derivative of just one variable. Now the area of this is just going to be x times y. And you also know the area it's given to you is 216 feet squared. All right, I want to have everything in terms of x. So what that means is I need to replace y. So here I'm going to solve for y. If I were to solve for y, I will have 216 divided by x, which is good because I'm going to take the secondary equation right here, replace it into my primary equation. So the p is equal to 2x plus 3 times 216 over x, like that. So let's go ahead and rewrite this. 2x plus 216 times 3 is 648. Move the x on top, x to the -1 power. Let's find p prime. So the perimeter prime of this is going to be just 2 minus 648 times the -1 is 648 x to the -2nd power. Now you want to set this equal to 0. Solve for x so that way you can find your critical point. So then I have 2 minus 648 over x squared equals 0. Move the 648 over to the right side. 2 equals 648 over x squared. Cross multiply that, you get 2x squared equals 648. Divided by 2, then square root it. You're going to get a plus or minus 648 divided by 2. Which is going to result in x equals plus or minus 18 feet. Okay, so I know that the x value here is going to be a positive 18, can't be a negative 18 because your length can't be a negative length in terms of feet. So now that I have this part here, I need to figure out what y is. Now you are aware that 216, which is the area, equals x times y. Well, now that you have x, you can replace the x with 18 times y, divided by the 18 on both sides. Y is going to give you 12 feet. I know you're like, well, how do you know that this is actually going to be a minimum? You could do a sign line and test it, but at this point, it's almost guaranteed that it's probably going to be a minimum. But just for kicks and giggles, x is 18, so you're going to do p prime of 17, or actually, you know what, better yet, you could do 0. That might be easier. And p prime of maybe 20 on the right side. And again, you're going to plug the 0 and 20 into p prime, which is this equation right here. No, don't erase that. This equation right here. So then when you plug it in, it's going to give you a negative and a positive. So you can verify that it is indeed a minimum at this point. So then here, that is going to be your dimension. Your length is 18 and your width here is going to be 12. Okay, now that we've done number 7, I want you guys to go ahead and give number 8 a try on your own. We actually did a question very similar to that one back in week 16 Tuesday, so give it a try. And when you're done with number 8, move on to page 2 of the review. And page 2 is on graphing and interpretation of graphing, F prime and F double prime. Okay, so then let's go ahead and go over the last question, which is on the 300 room in Las Vegas, which is question number 5, because I don't think we've done a question like that before. So let's give that a try. Okay, so just making sure that I'm still sharing this. Okay, good. Nothing will make me more agitated is when I spend like almost 30 minutes on a lesson and realize I didn't share the proper screen. I'm talking, you guys are looking at something completely different. I have no idea what I'm talking about. All right, it says a 300 room in Las Vegas is filled to capacity every night at $80 a room. For each $1 increase in rent, 3 fewer rooms are rented because if it's going to be more expensive, then people might less inclined to use the room. If each rented room costs $10 of service per day, how much should the management charge for each room to maximize gross profit? What is the maximum gross profit? Okay, so let's start off with talking about the rate. So the rate is going to be the change in rate times change the number of room rented. Because when you change the rate or the rate of the room, some people are less inclined to go there. Change of the rooms rented. It's kind of like a tongue twister there. All right, so then your R of X is going to be, it's $80 per room. So the change in rate is going to be $80 per room plus 1x because it's $1 per room. So X is the number of rooms. Okay. Times, I want to make sure I change that X because I don't need to think like multiplication X and the X signifying for the number of room rented are exactly the same because they're not. The number of rooms rented, well, there are 30 rooms altogether, or 300 rooms altogether, minus 3x, because 3 fewer rooms are rented. So for every dollar that you increase in rent, so minus. Yeah. So let's go ahead and FOIL this thing out first. So FOIL first. Outer, inner, and last. Combine your like terms in the middle. You should get 24,000 plus 60x minus 3x squared. So given the fact the question is asking you how much should management charge each room to maximize the growth profit? So what is the maximize growth profit? You're going to find the derivative of R of X. So then because R of X is the rate, and if you're finding the maximize of the rate itself, we'll do the first derivative of that. So that will give me a 0 for this. 60x becomes a 60. 3x squared is a minus 6x. Set it equal to 0. Solve for x, which is going to give you the critical point. And given the fact that this is going to be on a maximum, you kind of expect that you have a positive slope followed by a negative slope in order to get a maximum. So then my critical point is going to be 60 equals 6x, x equals 10. So x equals 10. X is the rent increase of this. And so here is the rent increase. And of course, if you're to do a sine line on this, here's my x, which is 10. You can do r prime of 0 on the left side, r prime of 11 on the left side, r prime of 11 on the right side. You plug it into this equation right here. And you should have that this is going to be a positive and r prime of 11 is a negative. So it should go up, follow, down. Okay, so then as I look at this, you know that the rent for each of the room is going to be 80 plus 1x, so the increase of $1. So then 80 plus 1 times 10, maximum amount that you should charge for each room is going to be $90. for the gross profit. So then here, your maximized profit is R of 10, which means you're going to take that, plug it back into the R of X, which is this equation right here. And that is going to give you, so 24,000 plus 60 times 10 minus 3 times 10 squared is 24,300. And that is your answer. All right, you guys, I will highly suggest you kind of play around with some of the other questions in between this. As always, stay safe and healthy, and I'll see you guys next time. Take care.